We all have learned about trigonometric ratios in our previous classes. Mainly we have 6 trigonometric ratios: sine, cos, tan and their reciprocals, that is sec, cosec and cot. Now, if we extend the idea of trigonometric ratios and if we go deeper into trigonometry, we have to learn something new, that is trigonometric functions. Trigonometric functions are functions which have well-defined domain and range. Like trigonometric ratios, we have 6 trigonometric functions, that is sine, cos, tan, sec, cosec and cot. Now you may have a question that what is the difference between this trigonometric ratio and trigonometric function? Trigonometric ratios and trigonometric function both dealing with the side and angles of a triangle. But trigonometric function have well-defined domain and range. Or we can say trigonometric ratios are the subset of trigonometric functions. Alright. Now let's see the mathematical aspect of trigonometric functions. Also we'll be dealing with how the signs of trigonometric functions vary in various quadrants. Alright. Now let's start with the mathematical approach. For that, we have to consider a unit circle with center at O and marking the points A, B, C, D. Now consider a point P of AB and join O to P, and this angle is X. And if I am joining this P to OA, this will be joining OA at M. Now OM is A and PM will be B and OP will be 1. What is sin X? Sin X is perpendicular by hypotenuse. So sin X is equal to B, and what is cos X? Base by hypotenuse, which is A. Alright. Now we know that in the triangle OPM, as per the Pythagoras theorem, we can write OP square is equal to OM square plus PM square. Now what is OP? 1 square is equal to OM is A, that is A square, plus PM is B, so B square. Now substitute A and B. So we get 1 is equal to cos square X plus sin square X. Alright. Now we know 1 complete revolution corresponds to 2 pi radians. Therefore, we can write angle AOB is equal to pi by 2. Angle AOC is equal to pi, and angle AOD is equal to 3 pi by 2. As you can see, these angles are multiples of pi by 2 or 90 degree in terms of degree measure. And such type of angles are called as quadrantal angles. I repeat, the type of angle which varies as a integral multiples of pi by 2. Pi by 2, pi, 3 pi by 2. These are integral multiples of pi by 2. These angles are called as quadrantal angles. Now one of the peculiar property of this quadrantal angle is that the terminal side lies either on the x-axis or on the y-axis, right? Now we have to calculate the quadrantal angles for various angles. Now we have to find the quadrantal angles for various angles. So for corresponding to 0 degree, A comma B, where what is A? A is equal to cos X and B is equal to sin X. Substitute the value 0 here. In cos X and sin X we get 1, 0. That means when the angle is 0 degree, it corresponds to 1, 0. That is at point A, it is 1, 0, right? Now when corresponds to pi by 2, what will be A comma B? Substituting pi by 2 in cos and sin, we get 0, 1. So at point B, the coordinate is 0, 1. Now corresponding to pi, it is minus 1, 0, because cos 180 is minus 1 and sin 180 is 0. Now 3 pi by 2, so corresponding to point C, the value is minus 1, 0. Now 3 pi by 2, what will be the answer? It will be 0 comma minus 1 because cos 3 pi by 2 is 0 and sine 3 pi by 2 will be minus 1. And what will be 2 pi? When value is 2 pi, cos 2 pi is 1 and sine 2 pi is 0. So you can see that we have come back to the initial point, that is 1, 0. That is at D we have 0 comma minus 1 and at A again we come back to the initial position. So one complete revolution take 2 pi radians. Alright. Now for any increase or decrease in sine and cos, the sine and cos value does not change. That is, in generally we can write sine 2n pi plus x will be equal to sine x. And also cos 2n pi plus x will be equal to cos x for all n element of integer. Now at certain values the sine value is 0 and at certain values we can see cos value is 0. Sine x is 0 at integral multiples of n. So that is for 0 plus or minus pi plus or minus 2 pi like that. So in generally we can write sine x is equal to 0 for x is equal to n pi. Now similarly for cos x is equal to 0 at odd integral multiples of pi by 2. That is for pi plus or minus pi by 2 plus or minus 3 pi by 2 plus or minus 5 pi by 2 and so on. So if we generalize, we can say cos x is 0 at x is equal to 2n plus 1 pi by 2, where the value of n is an element of integer. Next, we have to learn about signs of trigonometric functions. We know that we have 4 quadrants. First quadrant, second quadrant, third quadrant and fourth quadrant. We know that A is equal to cos x and B is equal to sin x. In the first quadrant, A and B are both positive. In the second quadrant, it is minus A, comma B because the y component is positive and x component is negative. And the third quadrant, it is minus A, comma minus B. And the fourth quadrant, it is A, comma minus B. Right? Now, you can see that A, B is positive in the first quadrant. That means both cos and sin is positive. And what about tan? What is tan x? Tan x is equal to sin x by cos x. Since both are positive, tan is also positive. First, we will deal with the first three, that is sin, cos and tan. We will consider the signs of these three. Alright. Now, in the second quadrant, it is minus A, comma B. That means cos is negative, sin is positive. Again, what is tan? Sin by cos. So, since one of the component is negative, tan will also be negative. Now, come to the third quadrant, both are negative. That is minus A minus B corresponds to minus cos x minus sin x. So, what will be tan? It will be minus sin x by minus cos x. So, we get tan as positive in the third quadrant. Now, comes to the last quadrant, that is fourth quadrant. There A is positive, that means cos is positive. And what about B? B is negative, that means sin is negative. Again, we get tan as negative in the fourth quadrant, right? So, we can say in the first quadrant, all sin, cos and tan are positive. In the second quadrant, sin is positive. In the third quadrant, tan is positive. And the last quadrant, cos is positive. Now, if we know the idea about the sign of these three trigonometric functions, we can ultimately find the sign of the other three trigonometric functions. So, there is a shortcut rule to remember this, that is all silver teacups. I am taking the first letter of that. A corresponds to all. S corresponds to sin. T corresponds to tan and C corresponds to cos. So what does it mean? In the first quadrant, all trigonometric functions are positive. Now, in the second quadrant, sine is positive. In the third quadrant, tan is positive. And in the fourth quadrant, cos is positive. So, this is how we have to find the signs of different trigonometric functions. And the last topic related to trigonometric function is, I told you trigonometric functions are functions which have well-defined domain and range. So definitely we have to know the domain and range of each trigonometric functions. Let's make a table. Let's start with sine, cos, tan. What is the domain of sine? It includes a set of all real values. So the domain of sine is R. And what about cos? This is again set of all real values, include the domain of cos. Now what about tan? What is the domain? Because tan is sine by cos, right? So we have to exclude those values where cos is 0. So that is, the domain will be R minus 2n plus 1 into pi by 2. Alright. Now, what about the range? Range of sine. It is ranges from minus 1 to 1. And for cos, it is minus 1 to 1. And for tan, it is set of all real values. So, we have found the domain and range of sine, cos and tan. Now, we have to calculate the domain and range of the other three trigonometric functions, that is cosec, sec and cot. Now, first we will deal with cosec. Now, if you know the domain of sine, we can find the domain of cosec. How? Because cosec is 1 by sine. So, we have to exclude those values where sin x is 0. So, the domain of cosec will be R minus n pi. Alright. Now, what about sec? Sec is 1 by cos. So, we have to exclude those values where cos is 0. So, which is R minus 2n plus 1 into pi by 2. Alright. Now, what about cot? Cot is 1 by 10, or we can write it as cos x by sin x. So, we have to exclude those values where the sin is 0. So, what will be the domain? R minus n pi. Alright. Now, we have to calculate the range of cosec, sec and cot. So, cosec, we have to exclude those values from minus 1 to 1. So, the range will be R minus closed interval minus 1 to 1. And for sec is also again R minus 1 to 1. And for cot, since tan covers all the set of real values in the range, cot range will also be the set of all real values. So, with that, we have discussed all basic aspects of trigonometric functions. We have seen the mathematical approach. We have seen how the signs of different trigonometric functions are varying in different quadrants. And also, we have discussed the domain and range of 6 trigonometric functions. Right? Now, in the upcoming video, you will be learning about trigonometric functions of sum and difference of angles. Now, let's have a quick recap.
Manorama Horizon. Learning made simple.